Welcome, everybody. Thanks for taking the time out of your day to join us. I'm going to quickly take us through some housekeeping bits and pieces, and then I'll introduce our speakers. We'll have two short talks of probably around 15 minutes each in length, following which we will do a Q&A session with however much time we have left. During the Q&A, we are in webinar mode at the moment, so please place your questions in the Q&A tab on your screen. Failing that, you can also put them in the chat. Martin and I will keep an eye on both. We will then read your questions out to the speakers and we can answer them live. If a question warrants a more in-depth conversation, what we can do is promote you to panelists, which will require you as the attendee to briefly drop out of the session, jump back in as a panelist, and you'll join us on this side, as it were, and you'll be able to turn on your camera and microphone. We'll cross that bridge if we come to it. So during the session, please put your questions in the Q&A tab or down in the chat as well. The other piece of housekeeping is that the session is being recorded. We will post the recording on YouTube so that more members of the community can access it and get value out of it. So if you don't wish to appear on the recording, then let us know. The only thing that would appear is any questions you ask in the chat, or if we promote you to panelists. I'm particularly excited about our session this morning because, as we were just speaking about in the practice session, I really feel that science fiction is a really universally captivating subject for everybody who has a vested interest in space, in astrobiology and exoplanets. It's something that really ties us together, and it really acts as a fascinating bridge between the scientific community and the general public. So I'm excited to introduce our speakers. We're joined by Julia Nováková, a founding member of the European Astrobiology Institute. She comes from Charles University in Prague. She recently presented a session at the Europlanet Science Congress a couple of weeks ago in Berlin. And she has worked on exciting projects like Strangest of All, published in 2021, and Life Beyond Us, published in 2023. Our second speaker is Eva Puranen, who comes from the University of St Andrews here in the UK, and has worked on exciting projects like Around Distant Suns, published in 2021. So welcome to both of our speakers. I think we're going to start with Julie.
Thank you, Callum, for the nice introduction. So I'm gonna share my presentation. Let me see. Let me know if you can see the slides. Perfect. So as Callum already noted, science fiction can help build bridges between the world of science and all of people, because it's an immensely popular genre, and it can help us imagine scenarios that haven't happened in the real world yet, but perhaps might in the future. So for the moment, imagine that you are sending a mission to Mars. You're part of the science and engineering team. You worked years and years on this, very hard, and now the spacecraft is on the way to the red planet to seek life. It's about to repeat one of the experiments on the Viking probes that NASA sent there in the 70s, which had a little inconclusive results, with a minority of scientists thinking that it actually might be indicative of life, although, again, it's very inconclusive. So we're about to repeat this exciting experiment in, let's say, more favorable conditions than right on the surface of Mars, which is extremely inhospitable, with no liquid water, lots of erosion, chemical extremes, and so on. So let's try to search for life on the red planet. But while the spacecraft is en route to Mars, a very hardy Earth microbe is discovered in the clean room where this mission has been assembled. And there are concerns that it might be able to survive in the subsurface of Mars if it encounters liquid water there. So you're faced with two options. Either you continue the mission to Mars with the possibility of contaminating the red planet and contaminating your own experiment that you have worked so hard on, but more importantly, introducing Earth life where none might be present so far, complicating all of future research, and perhaps if there really was some indigenous microbial life in the Martian subsurface, threatening it with these, let's say, invasive species. Or you can put a stop to the mission and lose those years of work and lots of dedication, support for the mission, millions of dollars and euros. And you try very hard to find out as much as you can about this novel microbe discovered in the clean room. But still, in the end, you're faced with the decision to either terminate the mission and maybe lose it forever because you might not get the same support to build it again, or you can risk potentially contaminating Mars, even though the risk seems quite low because, again, it's another planet with very different conditions from the Earth. And if the microbe encounters no liquid water, then there is no chance of it surviving in the long term. And the DNA from it might contaminate experiments, but there would be no risk of long-term contamination. And there is no easy answer to this dilemma. And this hasn't happened in reality, or at least yet, but it's the basis of the opening story of my anthology, Life Beyond Us. The story is titled Hemlock on Mars and written by Canadian science fiction author and aerospace engineer Eric Choi. And it shows us how we can apply science fiction to imagine future scenarios that potentially might be happening in the future, or in case of less realistic, less science-heavy science fiction, it can help us still imagine some future issues or dilemmas that we might be facing, such as if we ever find microbial life on Mars, what is going to be its legal status? Is there going to be some kind of protection of the site where it was found? Who gets access and who doesn't? How are we trying to protect this new species, this new biosphere? So these questions are not really answered by the current legal framework, consisting basically only of the Outer Space Treaty and then of many, many recommendations. So science fiction can serve to help us guide the way to solve these problems before they occur in the real world. And it's not a new thing. We have been imagining imagining alien life outside of the Earth for a long time. Before modern science and modern science fiction, it was present in many myths, such as the tale of the bamboo cutter, which originated in Japan probably in the 9th or 10th century. These are modern illustrations you see in the left. And it concerned a moon princess and her moon people. And in Europe, we can see more modern examples also by scientists, such as the posthumously published novel Somnium by Johanna Kepler, whom we know as an astronomer. And here, a young astronomer and his witch mother traveled to the moon and elsewhere using her witch powers. So nowadays, we would consider it more of a fantasy or maybe science fantasy. And they also encountered life on the moon, which again, at the time was not unthinkable. But in the 19th century, it was where modern science fiction started alongside modern science. And it took a lot of inspiration from it, which Emma is also going to talk about, especially concerning exoplanets. And one of the earliest modern science fictional examples of alien life are the Martians from the War of the Worlds by H.G. Wells, which is also a nice example of planetary protection, in this case in reverse, with Martians coming to the Earth. but dying in the end because their shells, which protected their bodies, got contaminated with bacteria, and they didn't survive this clash of the biospheres. And Wells was also a biology teacher by study, and it showed in his, let's say, popular science imaginations of how life might look on Mars based on what we knew in the late 19th and early 20th century. So he tried imagining how animals and plants would evolve like in the lower gravity and thinner atmosphere and less availability of liquid water. So these are just some of the imaginings that he published in Cosmopolitan in 1907, I think. And at the time, the consensus was that Mars might be inhabited, although probably not by civilizations, despite the claims of Percival Lowell and his fans of the Martian canals hypothesis. And Wells was also the, I would say, earliest example of trying to use science fiction directly in popular science, in science outreach, as we would call it today. And in 1894, he published a column called Popularizing Science in the Nature Journal. And there he argued for popular science books to adopt more practice of popular books and mysteries, such as Edgar Allan Poe's books, to elicit curiosity in the readers and guide them on the way to discovery instead of merely listing facts in like a telephone number list fashion. And we are basically continuing the trends outlined by Wells more than 100 years ago, because recent studies such as Elizabeth Stanway's survey of British astronomers at a conference, or more recent French survey by Bussier, showed that scientists often got inspired by science fiction early on, and it inspired them to pursue careers in STEM, which is something that we are trying to promote nowadays, especially as interest in STEM careers seems to be decreasing or steady but low in many European countries and in some countries elsewhere in the world. So science fiction potentially can help us change this and elicit more interest, more curiosity. And the imaginings of life in the solar system and elsewhere were pretty wild in the past, before we knew what Venus was like and what a greenhouse hell it was on the surface. There were imaginings of the Amazons of Venus and dinosaurs and huge, huge insects in the popular books and comics, especially between World War I and II. And although we now know that Venus is substantially different from these early imaginings, we can actually use them to contrast them with the current known image of Venus, and we can ask the question, okay, could Venus have looked a little like this, with a thinner atmosphere and liquid water in the past? And there are many models suggesting that the planet might have had oceans of liquid water for maybe as long as almost 3 billion years of its existence. So in the, let's say, astronomically recent past, Venus might still have been habitable. And although it was unlikely to contain any dinosaurs or huge insects, we can use these examples to imagine what life Venus could have potentially evolved if it indeed was habitable, which we still don't know, and future missions are going to help us find out. We can also imagine what life might be in the subsurface oceans, like the JUICE probe is going to study by doing flybys of the Jovian icy moons and by eventually going into orbit of Ganymede. So this is from the movie Europa Report, imagining what life might look in the European Ocean. And again, we can use this example to ask how likely is it that there might be enough energy and enough biogenic elements for such evolved multicellular huge life to exist in the ocean of Europa, or if it indeed has life, is it more likely that it's only microbial with a simple food chain. So again, we can use this example on the way to do astrobiology outreach. Similarly, we can ask a question whether alien life, if there are any intelligent civilizations, is more likely to look basically like humans, like the alien species in Star Trek here, Vulcans, or can it be very exotic, like the heptapods in Ted Chiang's Story of Your Life and the movie adaptation Arrival. And this leads us to the important debate in evolutionary biology between the role of convergence, arriving to similar solutions in similar environments, and contingency, basically the role of accident in evolution of life. So this is again a huge debate that where we can use examples from science fiction to get it closer to people and to enable them to imagine those two sides of the debate and which one may perhaps be more likely. And then there's of course the whole issue of potentially communicating with alien civilizations, if there are any. This is again from Arrival, and although the story and movie presented the communication in a more complex way than usually happens, at least in movies, most biologists and social scientists would still consider it very, very, very optimistic, and the odds of actually communicating might be much lower. And again, examples from science fiction, both the optimistic and pessimistic ones, can be used to explain why. And there are lots of science fiction books that use a lot of real science that can be used in education and outreach. These are just a few examples. And at the European Astrobiology Institute, we followed this direction in creating 2 science fictional anthologies with short stories followed by popular science essays, which Callum mentioned in the introduction. Strangest of All is available freely online on the website of the European Astrobiology Institute and on my website, so you can download it and check out the stories and their takes on life in subsurface oceans and exotic photosynthesis, SETI, the Fermi paradox, first contacts, and many more topics in astrobiology. And last year we published the more ambitious anthology, Life Beyond Us, which is available in print as well, and which contains 27 stories written originally for the anthology in collaboration with scientists who wrote the 27 accompanying essays on the many topics that are present in the book. I already mentioned the opening story by Eric Choi. We don't have so much time to dive into that, but I'll be happy to talk about it more in the discussions. I will also not brag, because I will let this slide to brag for me. And there are many resources if you're interested in using science fiction in outreach and education. This is a list of science fiction with good astronomy examples by American astronomer Andrew Fragnoi. Both Emma's and my anthologies are present there. You can check out papers that use science fiction examples to teach not just science, but humanities as well, such as this nice paper by Lockhart and Goggin from the Arizona State University. And in a moment, Emma is going to talk about how depictions of exoplanets evolved in science fiction before and after actual exoplanet discoveries, and how it also feeds into science fiction, including her anthology. And if you're interested in learning more about space sciences outreach using narratives and using specifically science fiction, we're going to have a debate and workshop at the International Astronautical Congress in Milan in 3 weeks' time. And we are planning lots and lots more activities, which mostly hinge on getting a course action that we are proposing and submitting in 1 month. And there might also be rigorous studies into how the depictions of alien life changed throughout the history of science fiction. Although, unlike in the case of exoplanets, so far we have no real example of life beyond Earth. So, science fiction may not be very realistic in many cases, but it doesn't need to be. As studies like Stanways and Bussius showed, it continues to inspire us to lead people into STEM careers and to take an interest in science, and it can be used as an important outreach resource. So I will stop sharing now, and it's your turn, Emma.
Thank you very much. Just give me a second to get my PowerPoint up. And play from start. Thank you very much, Julie, for that excellent overview of science fiction and outreach. And thank you very much to the Europlanet organizers for having me. Very excited to be presenting here today. So I am Dr. Emma Johanna Puranen. I've just finished up my PhD at the University of St. Andrews in the St. Andrews Center for Exoplanet Science, doing this interdisciplinary project on the portrayal of exoplanets in science fiction. So today I'm going to be telling you first about that, the science fiction exoplanets research with Bayesian networks. And then I'm going to be telling you about my anthology around distant suns, which I edited in the course of my PhD and which had a research component to it as well. So that'll be the second half of this presentation. So firstly, exoplanets in science fiction. So my thesis examined exoplanets in science fiction. Specifically, it analyzed the relationship between science and science fiction by looking at how science fiction responds to scientific discoveries, like the discovery of exoplanets, planets outside our solar system in the 1990s. With the aim of delineating science fiction's potential for science communication and use in evaluating public understanding of science. The study was motivated by wanting to investigate the information flow between scientists and science fiction creators and how ideas from science might reach the general public through science fiction. I focused on exoplanets as an area of science that has recently undergone a big change, their confirmation, their discovery. This NASA Discoveries dashboard, which shows real planets, not science fiction planets, features a lot of short period, high mass exoplanets that are very different from Earth, for example. And I wanted to know, have these discoveries impacted science fiction about exoplanets, given that science fiction was writing about exoplanets both before and after these discoveries? So how can we measure the relationship between scientific discoveries and science fiction world building? So for my methodology, I collected data on fictional exoplanets and science fiction. You'll see more of that in the next slide. And from that data, I created a Bayesian network to investigate the relationships between different characteristics of these fictional exoplanets. So what is a Bayesian network? It's a graphical representation of a joint probability distribution of a set of variables. It captures statistical dependencies, so how each variable influences the other variables. So this infographic shows the circles are the variables. And then for every piece of data I'm entering in, I have to categorize it according to each variable. Then the algorithm does something called structure learning, where it creates a whole bunch of different possible networks and scores them based on the real data for which one most accurately represents the real data. So the end result is a network that shows the relationships between the variables. For example, if you had one variable for whether or not somebody oversleeps and another variable for whether or not that person is on time, you're probably going to find a negative connection between them, with overslept being true, making it less likely that being on time will be true. So how does this work? I have this database of fictional exoplanets with 212 exoplanets by the end of my thesis. The published paper actually has less than this. And I have these 9 variables that I chose to create the Bayesian network. So I'll explain my variables by categorizing an exoplanet that's probably very familiar to everybody, Tatooine. So the first variable was after discovery. Is the fictional exoplanet from a piece of fiction before or after the discovery of real exoplanets? This one is from before. Hab zone is the fictional exoplanet in its star's habitable zone. This one is. Real star is the fictional exoplanet in a real star system. Like, is it fictionally in the Tau Ceti system, or is it in a galaxy far, far away? I think we know the answer for Star Wars. Life, does the fictional exoplanet have native life? Tatooine does. Intelligent, does the fictional exoplanet have intelligent native life? Tatooine does, but it's not humans. They're not native to Tatooine in the Star Wars universe. In this case, it's Jawas and Tusken Raiders. Humans breathe. Can human characters breathe the fictional exoplanet's atmosphere? They can. Medium is my only variable that isn't binary. That's just the medium of the work of fiction, and this one's a film. Is gas is just separates into gaseous or rocky planets, and this one's rocky. And then established non-native humans is a variable I sort of added partway through the process because I realized a lot of these science fiction exoplanets have an established population of non-native humans, and this one does. So I did that for every planet in the database, and I crowdsourced a lot of these planets, so it's not just from works that I had encountered myself. I had a Google form where people could submit various science fictional exoplanets. So for my results, this is the Bayesian network on the right here. And the circled things are my variables, and then the links between them are positive if they're blue, negative if they're red, and the black one on the bottom is just to do with the fact that media type is a more complicated variable than 2 states. So I'm very interested in this after discovery variable, and you can see that it has negative connections with established non-native humans and with intelligent. So in science fiction exoplanets from after the discovery of real exoplanets, you're less likely to find established non-native humans, less likely to find intelligent native life. And these 2 variables are sort of mediating after discovery's connection to some of the more positive cluster of Earth-like traits that all have positive links, like humans breathe, hab zone, life, etc. So results show fictional exoplanets have become less human hospitable, less Earth-like since the discovery of real exoplanets. The database is still very dominated by Earth-like worlds. Lots of science fiction exoplanets are very Earth-like. I think this is to do with the fact that science fiction is written by humans for humans, usually about humans. So it's a very different population than the real exoplanets on that NASA Discoveries dashboard I showed earlier. I'm not comparing the 2 populations directly. I'm only comparing fictional to fictional. But still, you're seeing a change. They're getting less Earth-like, and this mirrors real-life discoveries, which have received media coverage and would therefore be available to science fiction writers, even who aren't scientists. I'm thinking headlines like "World where it rains diamonds," "World with lava ocean," things like that. So this is evidence that science fiction incorporates new exoplanet science discoveries into its storytelling. And we published this in JCOM Journal of Science Communication and got a lot of reviews in science journalism outlets, Space.com, Universe Today, EOS. It was very exciting. I was getting lots of emails from reporters. Let's see, having trouble moving slides. There we go. Anthology project. So the anthology project came about because I was really thinking about the role of a science consultant in creating science fiction. So somebody who the author talks to, who is a scientist, who can advise on the portrayal of science in the science fictional work. I read an interview with somebody who was a science consultant on a Marvel movie and said that it was basically a quick chat with the director, and then he never heard anything again until he was sitting in theaters watching the film. But on the other hand, you have science consultants like Kip Thorne in the movie Interstellar, who modeled the visual wavelength appearance of a black hole for the movie and published real papers about it. And then a few years later, when Event Horizon got the picture of one, he was proven correct. So you've got all these different experiences. But I was like, what happens if you have a science consultant who is involved the entire time? So I got a group of creative writers together and a group of scientists together from the St. Andrews Center for Exoplanet Science. And I paired them up and had them each create a science fiction story based on the scientists' research. There was also a research component to the creation of this anthology that people could participate in if they wanted to. 5 of my 9 groups chose to participate, and they just had to fill in a questionnaire every time they had a meeting, which asked questions about what they discussed, story ideas, story decisions, and any communication successes or difficulties. So my research questions here were, what's the role of a science consultant for a science fiction story? How are decisions made regarding the portrayal of science in science fiction? And what is the role of science fiction in science communication? So we ended up with this anthology, Around Distant Suns, which has 9 stories. 5 of them are short stories, 2 are radio play format, and 2 are poems. These stories feature a whole lot of interesting science elements. There's a stripped core of a hot Jupiter exoplanet. There's a world where it rains graphite. There's sentient mist. There's talking clouds. There's life creation experiments. It's really fun stuff. And so for some findings, these are elements that I found to be true in at least 2 of the groups that chose to do the research component. There was a lot of hesitance from the scientists to contribute to story decisions or participate in the creative process, which was interesting. I had sort of assumed it might be the opposite, that the writers might be intimidated by the science. But no, the scientists were intimidated by the writing. In every group, scientists provided justifications for plot points, technical terminology relevant to their field. Several groups undertook research work during the writing process, like between meetings, they would assign themselves to go look something up and bring that back. A lot of the groups chose to focus on field work, scientific field work in their stories. A lot of the groups bonded by discussing a shared interest in science fiction. And then at the first meeting, groups were sort of split between, like every group had a Q&A getting to know each other, but some of the groups had more of a scientist focused where the scientist is always answering. And then some other groups had a more balanced question and answer where they were both asking and answering questions about each other. And several groups also chose to focus on a sense of ambiguity and mystery and related this back to the idea of science being about answering these big questions that we may still not know the answer to, and as well as stories getting a lot of, getting a lot of the way their narrative works being based on suspense, ambiguity, mystery. So here's just a few testimonials from people who participated. One group was talking about discussing the roles of scientists in society and how difficult it can sometimes be for a non-scientist to understand scientific results. Related to the sense of ambiguity and mystery, one group said, I think a great story is all about a question, but it's not up to the writer to answer it, it's for them to explore. One group, in talking about field work, it helped build the emotional truth of fieldwork research for me, which is really what stories are trying to capture and convey, while technical details are just the icing on the cake. One group about successful interdisciplinary encounters in this project. We both are comfortable to reach into the other's field of expertise with the expectation to be corrected and learn from it. And then one group, in discussing the use of these works for science communication, said that their goal was to try and inspire an interest in non-science-based readers and rather not get bogged down in the details of the science. So I think a lot of my conclusions from these 2 projects really boil down to, it's always the case that Le Guin has done it first, right? Le Guin said science fiction is not predictive, it is descriptive. That is, it's not predicting the future, it's describing the world around it and expounding based off of that. And I think that's true in a lot of these cases. I have found some evidence that science fiction changes with new scientific discoveries from the Bayesian Exoplanets project and from the participants in the anthology project, which really must be seen in the context of this being a strange collaboration that doesn't usually happen in the production of science fiction, as well as having a small sample size. But a lot of them found an inspirational, exploratory role for science fiction in science communication efforts. That is, it's not teaching all these things, but it's introducing concepts and inspiring people to go out there and do more research themselves. So thank you very much. I believe all of these links Martin will put in the chat, but that is my talk, and Julie and I will happily take some questions.
Thank you. Thank you, Emma, and thank you, Julie, for those talks. I found both really, really engrossing and engaging. Thank you, all of our participants, for engaging with us in the chat. Now is the time to post your questions for our two speakers. They can go in the chat or even better in the Q&A so that we don't lose them. While those come in, I just wanted to chat a little bit more about something that you raised, Emma, about the hesitance of the scientists when it comes to working on anthologies like this. I also found that really interesting because I would have expected for the scientists in that dynamic to be really excited about being able to publish their findings, being able to connect with a new audience, being able to gain publicity on what they do. So do you have any reflections on why that might be?
Yeah, I mean, I think it was that they didn't feel that they had the expertise to create an interesting plot line and narrative. There was one group where the scientist really got involved in this. The only group where the scientist ended up really contributing to the creative process and was sort of given homework by the writer sometimes to like come up with a plot arc and bring it back next week. All the other groups, the homework was more science-based. I think possibly part of it is that there's so much uncertainty baked into science that scientists, I think this is one of the big challenges with science communication in general, is that people want straight answers, and then scientists are always like, oh, well, here's the margin of error, and they can't really give a clear answer. So I think people were maybe a bit concerned about not giving correct information, and so we're hesitant on that front as well. And one of the interesting solutions that a lot of the groups reached is realizing, oh, actually having some sense of mystery in the story is really what hooks people. If you've got a story that answers everything and leaves nothing open, you're going to read it and then never think about it again. Whereas if there's some mysteries in the story, that'll be hanging in your head for weeks. You're going to keep thinking about it. So that was a pretty good solution to come to.
That's lovely. Yeah, I think. Sorry, Julie.
Yeah, exactly. I was just about to add that the questions are what's interesting and exciting, and we can use the same approach in science communication even without using science fiction, because when I, for instance, talk to kids in schools, I focus more on the questions than what we know with more certainty, because the questions are what they could be answering in 10 or 20 years' time with new space missions. I mean, is there life on Mars? Is there life on Europa? Or how do these subsurface oceans work? How deep are they? And the people that I talk to could be the next generations of JUICE scientists or scientists on other missions. So this is really something that can create curiosity.
I agree. I think we as consumers of any kind of content, we're captivated by questions that we can't answer. It creates a sense of mystery, a sense of wonder, and I think science fiction is a fantastic gateway for that. So yeah, it's interesting because I think uncertainty, for me anyway, is one of the most engaging features of the genre.
Yeah, and in astrobiology, there's a lot of talk recently on communicating astrobiology discoveries more responsibly and on emphasizing the uncertainty involved in the discoveries, because there was no surefire discovery of alien life yet, and there is unlikely to be in the foreseeable future. What we are likely going to get are some biosignatures, potential biosignatures that might be indicative of life, some interesting chemical disequilibria, which might potentially be caused by life, but we wouldn't know for sure. And this is something that needs to be communicated clearly, because already the majority of people across multiple surveys think that alien life was discovered already. And it's even the case of science students, as Arve Kotan found out in his surveys of students into Paris universities. So this is a problem that we should address, because if people think that we found alien life already, what sense are they going to make of new missions or of discoveries that are presented as not so surefire? So the scientific process and the uncertainties need to be communicated, and science fiction is one way among many to help with that.
Right. This is one of the challenges with the media as well. Again, like the headlines being short and punchy and saying something definite, and then or being clickbaity, and then you read the article and realize the title is entirely misleading. And that's a particular challenge with astrobiology reporting, because it is a field that has a lot of uncertainty in it. I did a separate project about the n=1 problem, the fact that we have one example of a planet with a biosphere. And in that, I interviewed 18 exoplanet scientists about how the n=1 problem affects their research. And one of the questions I asked was, do you think with current technology, it's possible to unambiguously detect life on an exoplanet? And every single one of them said no, unless it was a technosignature. So I think that indicates that the current people who are leaders of the field expect that we're going to have some ambiguous biosignatures, and it might take decades and decades to confirm whether or not that really is life. And that's going to be a huge challenge for science communicators. So we better be ready. I think one of the quotes that somebody in the anthology project put in a questionnaire about this uncertainty was something along the lines of, science is not only about solving the great mysteries of life, but also about admiring them. And I thought that was beautiful and fit in well with the fiction side of the project.
That's lovely.
Okay. We have one question in the quick Q&A from Johanna Bonova. And the question is, in science fiction, there is a continuum between what we could call hard science fiction, for example, The Martian, and fantasy, the adventure story that takes place in space. What do you think is the role of science communication on each side of the spectrum? Are stories on all sides of the spectrum effective to inspire young people to STEM careers?
Well, the short answer is yes, they are, because even if they are not realistic, we can use them as examples. I mean, Emma mentioned Tatooine from Star Wars, which is basically a fantasy adventure taking place in space, as something that we can use to explain the concept of exoplanets and the concept of a planet orbiting a binary star and still being habitable. We can, from this basically fantasy example, delve into the issues of habitable zones with eccentric orbits and around binary stars of different stellar types, and dive into the more technical details that are not really present anywhere in the story. And with a more hard science fiction story, we can sometimes get these technical details directly in the story. So we can use it, let's say, more easily for the purposes of education rather than more broad outreach. That's the case of some of the stories in Life Beyond Us, which were written primarily by authors with an interest in science or even a background in science and technology. But yeah, both examples are certainly useful in science outreach and education.
Yeah. Tatooine is always my go-to example for that, because it introduces the concept of a circumbinary exoplanet, which people might not be familiar with the term, but they understand the concept because of this space fantasy they saw called Star Wars. I'd wager that most of the people in this call were first introduced to the idea of a circumbinary exoplanet through Tatooine rather than through any of their schooling or their work. Maybe there's somebody who has never seen Star Wars, and maybe there's somebody who first learned about Kepler 16b. But yeah, that's a great example. And then, yeah, The Martian is a great example on the other side with the hard stuff. Andy Weir is a master of incorporating like true physical concepts and things in his works. I'm a huge fan of Project Hail Mary, and I'm very excited for the upcoming movie. My take on that is if they get the alien right, it'll be a good movie. If they get the alien wrong, it'll be a bad movie.
Yeah,
but I'm excited. I'm excited to see it.
Same thought here. And it's a great example of really exotic, intelligent alien life.
Mm-hmm. Yeah. So I think with something like the Martian or Project Hail Mary, you're not going to come out of reading it not having learned some science. With the other stuff, you could definitely come out of Star Wars not really thinking about science much. But if you have sort of the intermediary of a science communicator, they could take either and use it for science communication.
I think another nice example is The Expanse, which it's somewhere in the middle because it has sort of hard science, that's how it is. But then, of course, it has also some soft science fiction in the way, like communication is too fast. They're still communicating on a almost direct basis, which is, of course, for the film not possible otherwise.
Yeah. They also have, though, there's one scene where two people are in spacesuits and their comms get cut between the spacesuits. So they go up and sort of hold their helmets together, and then the sound is able to go through the atmosphere in the suit, through the solid medium to the other. Yeah, they can hear each other. And I thought that was really, really cool. So there are some really great moments where they use physics in that series. I've heard someone say, for The Expanse, physics is in the same room as the writers.
Yeah,
It's not way off, but it's not completely correct either.
Yeah, it's amazing. You sort of have the idea you're actually going through the solar system in that series. There's another question here from Ari, and Ari asks, have you found it difficult to switch between an academic style of writing and that for science fiction stories? I've tried to get into science fiction writing, but I can always feel the academic side bleeding through, and it's hard to keep that separation. Practice, I suppose, ...
Yeah, well, for me, it's not very hard. I always thought that it was helpful in both ways. And a lot of my science fiction stories were actually inspired by concepts I encountered in science and in the course of my studies and research. I'm an evolutionary biologist by study, and it shows in some of my stories. I hope in a good amount to really feed into the plot and the story to keep it exciting and not overwhelm it with academic details. I remember that in the class on the evolution of phenotype, so basically evolution of how a creature looks like and behaves like based on what its genes are, we discussed an interesting example of a peculiar zebra finch. And I was also just thinking about how we don't know much about the moth in elephants. So thus came a story that combined the two ideas, and also an idea of an animal psychologist trying to solve problems, combining ethology, the study of behavior, and neuroscience, basically connecting to the brains of the animals she studies. So that was the basis of the story, To See the Elephant. And in my space science fiction stories, I get inspired by actual discoveries in astronomy and planetary science. I like to use exoplanets that are not conducive for human life or for any life at all as settings. During my astrochemistry class, I did a class project on Coro 7b, and this planet, which is basically a hellish world that is very likely to be tidally locked, facing the star with one hemisphere all the time and the other drowning in perpetual darkness. And it's so close to the star that there is likely a lava ocean on the side that is facing the star. So there might be evaporation of metals and their oxides, and they might be snowing near the terminator, the line dividing the eternal day and night. And these metals might get fractionated behind the terminator. So I was thinking, wow, this is a really extreme world. What if people for some reason landed there and tried to extract these fractionated metals, for resources in a world where it's possible to travel to exoplanets. So that was again a scientific inspiration for a science fiction story. And it goes the other way too with science fiction, helping me think outside the box sometimes and come up with new ideas.
I think I actually have more trouble with academic writing than with science fiction writing. I think a key part of distinguishing between, because there are very different styles of writing. I think a key part of distinguishing kind of goes back to what I was saying earlier, is that in academic writing, you need to explain everything, all the assumptions, all the background information. And in a fiction story, in order to hook a reader and keep them interested, you have to leave them wanting more. So you can't explain everything. Every now and then you need to explain enough, but you want to suggest things sometimes. And I guess, yeah, you have to remember you're not writing an in-world Wikipedia article. You're writing, including all the information about the thing. You're just referencing a thing that is very normal in their world and giving just enough for the reader to understand and wonder a little bit more about what this thing is, and then get back into your storyline and your character. I think focusing on the character and their personality and how that sort of colors the writing is helpful. And also maybe trying switching what tense you're writing in. Maybe present tense might help you get more in the flow of the story. Things like that would be my suggestion.
Great. So we have new talent coming up, I think. So I would just want to make a comment about the predictive versus descriptiveness. I think one of the things that was predictive is this, iPads, because you see them in Star Trek, like in the early series, they have iPads, tablet kind of, they walk around with it all the time. Mm-hmm. Like, yeah, they didn't know that in the 80s. So I thought that was kind of cool.
Yeah, but I would argue back that the idea was already out there. And like it's a pretty natural concept to go from having like huge computers the size of a room to going, okay, what if we had one that could fit in our hands? Mm-hmm. The fact that the visual image of them ends up looking like what was imagined for TV is probably based on the fact that people who went on to create them grew up seeing them on TV. So I think it's more of I also call it a chicken or the egg scenario.
Yeah, okay, fair enough.
Like what came first? Yeah, I think the idea is out there.
Fair enough. Yeah, that's probably true.
There's an interesting feature of science fiction, especially when we look slightly farther back to, like you said, Martin, to people who are predicting a futuristic scenario and actually what features they imagine existing in that future scenario. And some of them now to us could look quite comedic and quite ridiculous, but then actually many others, as you say, Martin, like this kind of tablet feature are actually fairly similar to something that we have now. So there is sort of a role of prediction in some senses that is taken quite seriously, and in others that is designed to capture our imagination with something that could border on what seems like ridiculous at the time or looking back. But yeah, it's a fascinating role of the genre, I think.
Yeah. Just a quick comment on Ari's comment in the chat about transparent phones in the expanse. God, I hope not. Those always bothered me. It's like you don't want people to see exactly what's on your phone as you're scrolling. I don't understand.
We would lose them. I mean, I would misplace it as soon as I put it somewhere.
We make them opaque from the back and front.
Yeah.
Yeah, that's the key.
Anyway, so I had a question. If there's no other questions, I had a question about the Bayesian network that you showed the picture, because one of the elements was not connected to any.
Yeah,
the real star one, mm-hmm. Right?
Yeah,
and then also noted that the after discovery is only connected to three others.
Three, yeah.
But I would have expected that to be more connected. Could you comment on that?
Yeah, so it doesn't always find connections between everything. That doesn't rule out the fact that they may exist. It just didn't find it statistically significant with this data set. The real star one was interesting to me because I had thought that maybe that might be a proxy for how much research an author had done. For example, if they're setting it in a real star system, they would have had to look at some stuff about the star, but Nope, nothing. And that was consistent as I kept adding more planets to the database. So yeah, the connection with after discovery and media type is, as I said, there's 5 states for media type, which is the reason it wouldn't go positive or negative, because the states don't really have value. But that's mostly to do with there being more video games post 1995.
All right. And there was another thing that you mentioned, actually not in your talk, but in your paper, about the possible bias because of most science fiction being, Western European based, English literature based. How could you comment on that, and how could you, is there just not much science fiction literature out there in other languages? I'm not quite aware.
So that's a great question. That's a bias that I acknowledge in my data set. It's mostly English language Western science fiction. I have a few works in translation. For example, I have the 3-body problem in there. I have some works by Stanislaw Lem, but that is currently a bias in the data set. One way we tried to address this, because one of my advisors was from the School of Modern Languages, and she got interested in studying space topics by researching languages on the International Space Station. She did a project where a bunch of undergrads who are multilingual translated some science fiction into their other language and some from their other language into English. So we were able to get little bits about fictional exoplanets in other languages that way, but it's not enough to make the exoplanets my database representative. That said, I don't actually have data for like the number of science fiction stories that exist in various languages. I'd be very curious to read more about that if anybody has a study available.
Wonder about, like, in whatever, in Indian language, or just in Russia, in Russian language, there must be a lot of science fiction as well.
There would be a lot, yeah.
In Spanish and South America, whatever.
Yeah, and a lot in Chinese beyond what was translated into English. I mean, Chinese science fiction had a big boom recently, caused partly by the success of the 3-body problem trilogy. And there are more and more science fiction writers who are also being supported because the government thinks that science fiction can help us imagine new technologies and also inspire people. So there's actually like organizational support for science fiction writers, and many have been translated into English, at least in terms of short stories. I mean, Clark's World published a lot of Chinese science fiction, and they also have a new project on science fiction stories translated from Spanish, and they did some Korean stories and some Japanese stories, I think. So there's more and more translated science fiction out there, at least in terms of short stories. It's more expensive and harder to translate whole novels.
So Gurai is posting an interesting question and a link here. So he's posting it to everybody, so we can.
I mean, we had a few translations in Life Beyond Us as well. And I mean, stories written by international authors. We have people beyond the US, UK, and Canada, but also writers from Germany, from Brazil, from China, from the Czech Republic, and the scientists are basically from all over the place.
All right, we are slightly over the hour now, so I'd suggest we start to wrap this up. But thank you both to our speakers, to Martin, and for everybody in attendance. Thank you for taking the time out of your day, and thank you actually for engaging with us so consistently in the chat. That's really amazing to see the conversation going beyond just the panelists, but to the entire group as well. So thank you for that. The recording of this session will be made available very shortly on the Europlanet YouTube channel. I'd like to again just extend a huge thank you to Julie and to Emma for coming to speak to us today. I think the discussion was really interesting, and the presentations were totally engrossing. So thank you, everybody. Again, I hope that we will see many of you on Friday for our third installment of our Juice Science webinar series. The link for that was in the chat. It's also available on the Europlanet social media and should have been circulated to you if you are a current Europlanet Society member, to your email inbox as well. Thank you again, everybody, for engaging so heavily.